Alright, another draft physics video production. Uh, Not really in the mood. Sorry. No useful comments and computer. My document folder just disappeared in Linux Mint. Just gone. Just it's gone. It's just kind of irritating. I had some documents in it that were, actually useful, and just nowhere to get it back. It's gone. Anyway, just these. Maybe it's just some glitch thing from nowhere. yeah, yeah. Maybe it's not some real problem, but just strange. Maybe the hard drive did something. I don't know. Just bizarre. No, I didn't delete it by accident. No, didn't happen. It's just stupid. Computers. Anyway, so it just adds to the, you know, bunch of things. It's always a bunch of things. Well, it isn't always a bunch of things, frankly. Just sometimes there are a bunch of things in a row. It just doesn't put you in much of a mood. So I'm not in much of a mood. So anyway, I just thought I would go through some of the stuff. I'm attempting to put this in terms that can be understood by people. It's simple. It should be doable. But I, don't like it if it isn't doing it quite right, if things aren't in the right order or something. And so this writing thing I'm just having difficulty with. So anyway, I'll read this part and explain what I like and don't like about it. Alright, so let's just start over. Physics. Start over. Pretend we've drawn no conclusions. We just have experiments that give us indications of stuff. And so I would say there's indications of what I'm going to argue for. And see, even that's a useless way to start. So anyway, let's start with a clean slate, a great expanse of truly nothing. So I guess I should have an image of nothing first, because I guess people will be confused. Well, that's not an image of nothing. Anyway, now introduce a very simple something, a dense field of simple little bits that have a short list of simple properties. Okay, in open space they move at constant speed, the speed of light. Force, see? If people just did that one change, the speed of force, maybe I wouldn't have to explain any of this, because it would keep getting in their face, and they would keep realizing, oh, this is all the same stuff, isn't it? This magnetism stuff and whatever this fake electric field crap is, in the sense that it's not any different than the magnetic field. It's the same thing. It's either a repulsion or an attraction. It's moving things. And why are the things moving? Well, that's because the force around them changed, and now they're moving because it's imbalanced. It's that obvious. Well, anyway, it's that simple. Okay, constant speed in straight lines. So little things, little bits of momentum is what the universe is essentially made out of. And so we'll get to the second point. They come in two types. So this is the part where you have to complexify it a little bit. You have to, oh shit, I have to add two things, two simple properties. It's just too many for people. But yeah, they come in two types, the electron reflecting bits and the proton reflecting bits. And I've highlighted them in red and blue to make it more obvious. But they're all the same thing, really. They're just momentum. And one piece of momentum is going to react with electrons, and one piece of momentum is going to react with protons in the inverse manner. And that's all you need. That's, frankly. Consider the implications of such a field in motion. Sorry, I'm cold. The furnace is on now, and so that's probably making a mess of this audio, but nothing I can do about that. And such. Anyway, this house is, well, whatever. Consider the implications of such a field in motion. Perhaps you can understand that it would create a kind of even pressure. So this one, people should be able to get that if I got in there, I would realize pretty quickly that something's hitting me here, and then something's hitting me here, and something's hitting me, and hitting me. And if I add up all the hits, though, it's all pretty much the same. And the way to understand it is to understand that it's just little bits of momentum. And understanding it as momentum is probably part of the part that people just don't get. That all these fields. See, I wanted to just start with, well, I'll read this and then I'll explain that, yeah, the way I'm saying I should rewrite it is to start with a different premise. Considering the implications of such a field in motion, perhaps you can understand that it would create a kind of even pressure, that every point in the field would become a point of intersection or convergence, just like the gravity models. Einstein's gravity is taught as basically just a fluid converging in a point. Yeah, just like what those little bits would do. Effectively bombarded from every direction. If you were to place a still object in any position in the field, it would be constantly jostled by a pushing force. There's no pulling happening, just pushing, just hitting. Coming from a constantly changing direction. And so you could understand, if the field's even, I'm even. If I get more stuff hitting me at one end than the other end, then I'm going to be sort of pushed in that direction. So if you thought of little bits as even little bits of light, you could understand that light would do the same thing. If you had enough light hitting you from external source. So if you took you put yourself inside of a big globe, and the globe was made of light emitting diodes, and it shot the diodes at you, all the light from all directions, and you could sit in the middle and there'd be so much light, and then you could move somewhere else and there'd be the same amount of light. You'd just be getting more from one direction than the other direction. Well, you really wouldn't be frankly, because you're exposed to more of the other direction. So the light would be even no matter where you went inside. Make the globe preferably big, okay, and you'll get the idea. And if you really think about it, you'll get the idea that you really can't change how much light is hitting you. No matter where you go, the same amount of light's going to hit you. So the light analogy is probably one to use here to understand it. Yeah. Alright, now introduce a second still object close to the first. Now, this is not the greatest drawing of that, but really, if people are going to get any of this, they have to be able to. If they can't get this, then they probably can't get the whole subject. It's just not going to work for their brain if they can't get it. Alright, perhaps you can understand that the single objects will be profoundly affected by the other object's presence, in the sense that if I am in that globe and I get the same amount of light no matter where I go, because if I go closer to the diodes over here, yeah, I'm further away from the ones over here, but there's more of them, a lot more, and so I'm going to get the same amount of light on both sides no matter where I go. But if I put another object in there, then there's going to be a shadow thing. Then there's going to be clearly one side of me, wherever the other guy is, in his direction, is going to be a dark side. There's going to be less light hitting me from that side. I'm going to be shadowed from the force, and if we thought about light as a force, I'm going to have more light hitting one surface than the other surface, and if we thought about it as momentum, it's going to move me towards the other person. Just a fact, the other object. And right there you have the essence of gravity, that it encapsulates it very well. And now all you have to really understand is why does this repulsion and attraction thing happen through charge, and that only just has to do with the subtlety of the fact that electrons and protons are different, and they're reflecting light differently. So they're not just like putting an object in space, they're putting an object that just reflects a certain kind of light. So to use the light analogy, let's just imagine that the universe is lit. Okay, so where you see the dark now, it's not dark. Okay, imagine that's light coming from a distant place. And it's all around us, everything in the universe. And then just turn all the suns off and the galaxies, they're no longer producing light. Just imagine that they're in this field of bright light force. What would the consequences of that be is that you'd understand that all the places where the light doesn't hit you, all the little stars and the galaxies and everything, they would be shadows. You would be in their shadow. They would be blocking light. And you therefore would be, if the light is pushing you, you'd be getting hit by more light from some object that was closer to you, creating a bigger shadow. If there was more shadow on one side of you than another side, you're going to move towards the side where there's more shadow. And that's simple. Alright, anyway. Now the straight line pressure, and you got to understand it as a straight line force. So all this ether crap and wave crap is just kind of useless in terms of understanding. So, let's just do the obvious thing. Two objects. Alright, and it's a straight line force coming from all around, and kind of obviously all the stuff that would have hit here because of this object, all of these straight lines obviously will not bend around and go like this. So that's all pressure that will not, okay, it just will not get here, okay? And it has to get here for this to be even, because this is getting hit by the full pressure over here. So clearly both of these guys have a problem. This guy's not going to get hit by this, okay? This should be getting to this one, and this should be getting to this one. And neither of those things are going to happen. And they're going to happen directly proportional to how big this mass is, how much ability it has to block light, how opaque it is. So you could say opacity would be like being your mass. And you can understand that the more opaque you are, the more light that you absorb, the less that you're going to let hit the other guy, the darker the shadow you're going to create. That's simple. It fits what we see in the universe perfectly. And all you need to do now is to understand that, it's a little bit more complicated on the atomic level, because there's two kinds of stuff, as we kind of know. We have this stuff called positive and this stuff called negative, the electron and the proton. And then we have the magical dipole, which is, the magnet, which is just the same concept, just smashed together into this thing, this functioning dipole. And the only argument is going to be is that these things reflect differently. The red does reflect off the red, so if red goes in, red comes out. But if red hits the blue, now it gets deflected. So there's a difference. And if blue hits the red, okay, it gets deflected and no momentum. So the red causes momentum to the red thing, and the blue causes momentum to the blue thing. The reflection is a consequence of an exchange. Okay, so it's just a simple way of understanding where does something get movement from. What is movement? Movement isn't the kinetic idea as much as it is pure kinetics. Pure kinetics are a little different than the kinetics most people are familiar with. And it really isn't like you just hit it. You have something and you just hit it, and it just by some sort of magic absorbs the energy and just goes. No, it actually has to absorb it. And what electrons and protons do is they actually consume this thing that comes in, and they give back the opposite thing. Okay, so the reflection isn't just a reflection. The reflection is a change in the potential of this object, because this object is holding its history. It has its history in there. It's been hit by this and this and this and this, and has a little history, and it's exchanging a piece of its history. It'll give you this, and it's going to give back the most opposite to that. And so now this thing has been changed in the sense that it's going to have motivation. Its history is going to say, when I add up your history has a bias in this direction, and that's the direction the thing will move in. And that's how real momentum happens. Momentum doesn't happen by just some idea that you hit it and it goes. No, you change it when you hit it. You affect it in a real way, not just a synthetic or superficial way. Alright, anyway. So yeah, let's explain the straight line part anyway. Now the straight line pressure will not be able to reach all surfaces evenly. So you can understand that this ain't going to get there and this ain't going to get over here. And so now their worlds have changed. The universe this guy's sitting in and the universe this guy's sitting in is changed by this thing being there. Alright, this circumstance invents the shadow, and with it imbalance. Obviously, the balance changes. This thing will move really, really slowly. This force was moving the speed of force very, very fast. This force won't get here until this thing slowly gets here, and then the force will get here. But right now it's stuck inside of this thing. Alright. Invents the shadow, and with it imbalance, and with that movement. So movement is absorbing energy, and you can't do it any other way. You have to actually absorb the energy. Yes, you give some energy back, but you give energy back in a different direction than that you took. And that's the key to the whole thing. Through this mechanism, the material universe is pushed together, not so much by the presence of force, but by the shadow of absence. So, I think this is fairly well written. Problem is, like I said, is a continuity issue. This isn't really the way to begin 2 + 2 + 2 physics, because the argument is you have to know all the twos. So again, it is so simple. That once you understand it, it's so simple how it all fits together. I mean, it's just so, it answers all the questions. So let's understand, there's just two kinds of force moving the speed of light. And it can be in the form of photons, or it can be in the form of magnetism, charge, electricity, however you want to describe the momentum. But it's always, the momentum's origin is always these little bits moving the speed of light. So you only have two kinds, the electron reflecting bit and the proton reflecting bit. That's it. That's your first two. Then you only have two kinds of matter, really. All right, and as I've explained, there's no role for any of these positrons, neutrinos, muons. All of this crap doesn't have any role to play in the basic, even conventional physics, basic understanding of what makes an atom. What makes an atom is electrons, okay, protons, and the key ingredient is this weird thing called a neutron. And all you have to understand is that, as physics has demonstrated, this weird thing called the neutron, which it's only called the neutron for an ironic reason. So when this thing decays, when they take it out of an atom, and it falls apart, and what does it fall apart into? Well, it falls apart into a proton and an electron. So these are the only elemental bits, is this positive and negative crap. Alright, the neutron is sort of a lie. There's no neutral particle. It's just neutral because it has both bits. It's really a dipole. And the bits are so close together that there's no, you don't see it as a dipole. As soon as you get a little distance away from it, this is where the purple and red and blue thing start to make sense. But I'm just saying, you can imagine that if the blue is coming out of one end and the red's coming out of the other end, that the two are going to mix, and most of this will just turn purple from a distance. So you'll never see the dipole. You'll never see that it's made of the two elements. But the key thing is that just understand that the nucleus isn't just protons. There are some electrons in here, and inside that make up the neutron. So I could draw a neutron here. This would be the neutron, and this would be the proton. You can understand now there's a relationship here that's sort of interesting, in the sense that now you have a force dynamic where it's all deflections, right? I mean, any red force deflects off the blue thing, any blue force reflects off the... What happened to the blue one? Yeah, I lost my blue. Any blue force would be deflecting off the reds, and so you'd end up with very low pressure between them, and these things could get very close together, and that's your nucleus. Your nucleus is just protons and electrons in a clump, and that's basically all there is. is, protons and electrons, and the neutron is just a composite. It's, fool's gold. It's not what it's been sold to be. It's not what it is. And there's not really some strong force that's holding the protons together. You see, we know they hate each other, and yet they're very close to each other in the nucleus. Well, they're there because of these electrons. The electrons are what's mitigating the pressure. So it's really not a strong force. It's an incredibly weak force, in the sense that it's the weakness of the force between these objects that make them possible for them to be close together. But that's all you need, is electrons and protons. So all of the electrodynamics of an atom can be explained. You can explain why atoms are polarized, because electrons are on, there's more of them on one side of an atom than the other. There's some sort of distance rules. Something that stretches or compresses, you can understand how they would polarize, and so all that is explained, easily explained. So all you got so far is two kinds of force moving the speed of light in a straight line. Simple enough. Two elemental bits of momentum that start the game. The game, this is like the checkerboard. It's just the basic thing. So all you got is that and this, okay, and you got a lot of it filling the universe. And then you add two things, just this, a matter bit. Okay, and you have two types of those too. So two types of matter, and you have the simple actions, the two kinds of interactions. So 2 + 2 + 2, and then you have two kinds of interactions. Your interaction can be a deflection and no momentum this way. How to draw that? Slash through it. No momentum, or it can do what looks like a reflection. Okay, but it's really momentum in this direction. That's the end result. So those are your two choices. You can deflect a force, or you can absorb a force. So the force either goes in, or it ends into the object, or the force just deflects into a new direction. And that's it. That's all there is. Everything can be explained with these simple pieces. You don't need any neutrinos. You don't need any of this, entanglement crap. You don't need any bullshit at all. And you can understand why this stuff starts coalescing, and why very specific relationships could be created because of the fact that these two things are reflecting in, very different ways. And causing pressure on each other in different directions, and that they can be in a tug of war with each other. If I put enough of these electrons and protons around here, then I can have a relationship between them where, they're, where this one's creating, let's come up with an international symbol for attraction. I don't know what that would be, so let's just use a squiggly line. They would be attracted, and these two would be repelled, but they're being attracted here, so there's attraction between them here. And then these two hate each other, so repulsion will do with, I don't know what else to do except some sort of double arrow thing. So you have this repulsion here, and attraction here, and repulsion, and all of that ties up and creates geometry. There's going to be specific geometries that are going to be likely to occur because it balances the pressure. So yes, squares and triangles and hapsapodoids and all kinds of different things can be created, in terms of the geometry working to maintain the structure, to keep it from breaking, to make it quite shakeable, and they all stay connected to each other because they spread the pressure around to each other. So all of it can be understood with this simple. It's just my job is to explain how, and I have done that in the previous videos. I just need to put it now into some sort of ordered conversation. So the next part I want to just say here is something like, well, look, there's gravity for you. So we've already got gravity, sort of owned. Now, the subtle truth is it's a little more complicated now. So for gravity, it's really all of this kind of stuff is happening. Okay, I mean, gravity is made out of electrons and protons and their interaction. But the key thing to understand about gravity is that the gravitational bodies, you know, all these magnets, you know, that make up, you know, they have all these atoms, and they have all these red and blue bits. Now, if you understood this as being, as I described, you know, this magnet, well, probably shouldn't draw it that way because it's not very magnet looking. All right, so this magnet, sorry about the glare too, you know, tough crap. So there's no way for, I don't have a purple, okay, but understand that when this blue stuff and this red stuff, okay, hit a location, it's always going to be another charged element they hit. They're either going to hit a red or a blue. They can't hit anything other atomically. So even if this is a big huge magnet, it still can only hit a red or a blue. And if it hits a red, it's going to be attracted and repelled at the same time by this object. One side's going to repel it, one side's going to attract it. So you can understand that from this point of view, there's if it can't go in one of these two directions, obviously you have to put it far enough away where you get the idea that it can't really just turn and move towards the one side it wants to go to. So it has to be far enough away for you to get the idea that it's really is this is like it's seeing one object, and what it's really seeing, it's going to be seeing some kind of neutral, you know, some sort of mixture of blue and red, or attraction and repulsion, and they're going to be even. So it's going to be just as attracted as it is going to be repelled by the whole structure. So it's just going to sit there. It's not going to be compelled to move. But yes, if I move it over here, you could clearly understand that the influence from this repulsion is going to be so much stronger than the influence of this attraction. It's going to be so much further away, and so now it will move dramatically, because there's a huge imbalance between the two influences. So it's just kind of understanding that, like I said, if you use the light example and just use this force and imagine it as being red light and blue light, you can understand that what magnets can do is, yes, up close you're going to see the red and the blue, okay, but from a distance, further away you go, it's going to look all purple, and that's all you're going to see is the purple. You're going to see a mixture of attraction and repulsion. And so to understand gravity, you're just saying, okay, all this is still happening. It's all doing this magnetic charge kind of reactions. It's all electrons and protons and electron force and proton force, and it's all charged. But the point is that with big suns and earths and things, there's no good magnetic field because all the atoms, okay, are turned in all kinds of directions, and so any magnetic effect is totally undone by the fact that they don't have they're not going to produce a field that's, you know, strong, because it's not going to be well segregated. One side isn't going to do one thing and one side do the other. It's going to be mixed all the way through, and so you're going to end up with purple everywhere. So it's all just one effect, in the sense that just as you hit just as many electrons as you hit protons, you get just as many proton interactions as you do get electron interactions, and so in the end you can't get any of the, you can't take advantage of any strong attraction or strong repulsion, because you've eliminated all that, and so all you have really is the force, and how much of it did you absorb. So really it's just going to be about how much did you move these little bits by making exchanges with them, and that's all it's going to be. So it's not going to be polarized. So it's going to be the unpolarized force. And so I could argue to you, if you could understand the basic concept, that if the force comes in these two types, red and blue, and then when you mix them, you weaken that force substantially. And that's why there's such a huge difference between what they claim to be the strength of gravity and the strength of charge. And it just really has to do with how much of it you're leaving, how much blue and how much red is visible. Because with charges, if I put the magnet far enough away, it'll all look purple, and there won't be any effect besides gravity. That's all you'll have left. Yeah, it's just. So anyway, so my challenge is like I like the boating analogy. So that's one way of explaining the key to the whole thing, which is really understanding that force is absorbed. It goes into the object, and the object exchanges, and that creates a new bias in the boat because you've changed a rower. Good analogy. And this light analogy is a good analogy for understanding this, how simple it really is. And it's perfectly consistent with all the experimental evidence. It perfectly explains why magnets attract and repel, perfectly explains the concept of charge, perfectly explains why atoms stick together, why atoms connect to each other, why all this crap happens. It fits, and there really isn't a problem. And for those who, like I said, new people, they might say, oh, drag. As I pointed out, drag is a real problem for protons and electrons. They are dragged into submission to dilution by the field. The field does dilute their velocity. And matter, big matter, is a special case, because big matter arranges these little fellows in such a way as to take advantage of the free right turns that happen when you hit the deflections, and it can take advantage of those deflections to perpetually trap momentum in a direction. And that's why wrenches can fly forever through space and electrons can't. So anyway, it covers it all, and just again, my job to just point out something so simple. I mean, you feel like you're explaining the alphabet or something. It just seems so rudimentary. Yes, this is what we know exists. This is the stuff you have solid evidence for, and this is all you need to explain the phenomenon we see. Why magnets attract and why magnets repel. Perfectly understandable. And the rest of it is even more simple. Alright, so that's probably enough of a video. We'll see if in the future I can time my videos better without furnace. Hopefully it's not too bad. It's just a rumble, so it shouldn't be the kind of noise that is too distracting. So anyway, yeah, that's enough for today. All part of the challenge, blah, 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 blah. And I need to find an adversary willing to argue how this is in any way flawed as an explanation of reality. How it is less complete than the standard model, which is rubbish, in terms of it doesn't say anything on almost any of these subjects. The standard model doesn't explain where the energy comes from for gravity or magnetism. No explanation. Nothing. Virtual photon bent geodesic. It just made up nothing answers. Why is my finger held up? Yeah, so there's just this. I need to have the argument with somebody who thinks they're a smart ass and knows physics, and they can explain how their model more completely answers the questions, which this one is completely complete, and does it simpler. And clearly theirs isn't simple at all. I mean, you can't even really complain about its complexity because it doesn't have any. Alright, so I mean, obviously bent space is simple in the sense that you just made up something that has no physical reality, and it doesn't have any physical structure, and it doesn't have any physical mechanism, so of course it's I can't argue with the simplicity of the Invisible Man as a suspect for a crime, but we're saying who meets the evidence and who more completely explains the physics. Okay, so my explanation is more physical, less invisible men are in it. It's simpler, and it's more complete in terms of the answers it provides, the explanations it provides for why things look the way they look. Alright, so that's all I can do. Keep mechanically going through this process of, it's definitely a job. I mean, there's just nothing fun about having to do this. But anyway, till the next time. And such. I think that's all there really was. The simulation, I haven't heard anything, but it should be coming along. We'll see. So something should be showing up soon that looks like electrons and protons. Anyway, till next time.